Thank you for joining this lesson. We're going to discuss angle properties of circles, chords, and tangents. Remember to subscribe to this channel and to also share the link with friends. In number 23, we are told that in the figure below, K, L, M, and N are points on the circumference of the circle center O. Then we are told that the points K, O, M, and P are on a straight line. Then PQ is a tangent to the circle at N. Angle KOL equals to 130 as indicated, and angle MKN equals to 40 degrees, just as indicated. Then the question goes, find the values of the angles, stating the reason in each case. The first angle to be found is MLN. MLN, so the angle at this point. What we should know is that when we look at a chord like MN, the chord at this point, this chord is producing an angle at the circumference of the circle whose value is 40. And the same chord is subtending the angle that we need to get. Therefore, we should simply conclude that the angle MLN is equivalent to the angle NKM which is equivalent to 40 degrees. And the reason for this is that these are angles subtended. Angles subtended by the same chord, because it's known very well that angles subtended by the same chord at the circumference of a circle are always equal. The next thing is to calculate angle OLN. OLN, the angle at this point, OLN. Okay, we can do this one systematically. We can begin considering KL, which is a chord that has produced 130 at the center. Then we will be able to conclude the values of the angles at this point. It means there is in the triangle KOL, there is a 50 degrees, which should be shared such that we got a 25 here and also a 25 at this point. And again, we should also know that with 130 degrees at the center, and there is an angle at the circumference of the same circle, then that angle should be half of 130, and that is 65 degrees. So we have 65 degrees at that point. Now that we have 65 degrees at that point, and considering triangle KNL, this angle is also 65, then we can make two conclusions, and that is the length KL must be equivalent to LN, because these are equal angles, 65 and 65. Then we can get the value of this angle such that from 180, from 180, we use my calculator so that I may be very accurate. From 180, we can subtract. There is a 65 and another 65, then a 25. So the other angle there is 25. The angle at this point is 25 degrees. So if that angle is 25 degrees, then now that is what we wanted, 25 degrees. The value of this angle is 25 degrees. Angles inside a triangle. Angles in a triangle, because that is the concept we have used just before arriving at the answer. We might have applied several concepts in the process of pursuing the value of a certain angle, but the reason that you provide is the one which is just immediate to the answer. LNP, angle LNP. So LNP, now the value of this angle it's good to know that the value of this angle is equivalent to this one. This is a 65 degrees. So we're going to have 65 degrees at that point. 65 because we have a chord LN which produces an angle of 65 at K. And the angle, the chord NL is making an angle with the tangent QP. We usually say that if a chord makes an angle with a tangent, the chord subtends an equal angle at the circumference in the alternate segment. Therefore, the angle is going to be 65 degrees. 65 degrees because it is angle made by chord and tangent and angle in the alternate segment. We call it angle in the alternate segment. Angle in the alternate segment. We have another angle, MPQ. MPQ, the angle at this point. Now that we are having 40 and 65 twice, then the value of this angle, we can use angles in a triangle and we consider KPN such that we have 40, 65 and a 65, which is 130. Then we get the remaining angle. Therefore, we will need 180 minus 40, 65, 65. So that will give us the remaining angle. Remember, this is 130. When we add 40, we get 170. So the remaining angle will just be 10 degrees. And these are angles in a triangle. Angles in a triangle, which must add up to 180. Finally, we are finding the angle K and Q. K and Q, the angle at this point. The angle at that point. Okay, the angle might have several approaches. That is, along a straight line, the remaining angle, because we already have 65 and 65, which is 130, so the remaining angle is going to be 50 degrees. That is one way. So we can have 180 minus 65 degrees and 65 degrees, which give us 130. So 50 degrees angles on a straight line. Angles on a straight line. So now that is one reason. Alternatively, a student can just consider the chord Kn, which is producing an angle in the alternate segment, which is equivalent to 50. Therefore, the angle made by this tangent and the same chord is supposed to be 50 also. Therefore, that could be another approach.